Welcome to Algebra 2. In this video, we're going to look at arithmetic sequences. This is a type of sequence where we have a constant rate of change. This means that each pair of numbers has the same difference. So we will be constantly adding or subtracting the same number. So in order to check for this, we're going to subtract each pair of numbers and see if it's the same. If it's a constant, it is an arithmetic difference. Let's look at our first example. We're going to determine if this is an arithmetic sequence. So what we need to do is find the difference between each pair of numbers. So our first set is 22 to 32. Now, when these are whole numbers, you might be able to do this in your head. Some of them are decimals, so you'll probably use a calculator. In this case, we would take 32 minus 22, gives us a difference of 10. Okay, then we check the next pair. 42 minus 32, also a difference of 10. 52 minus 42. 62 minus 52. And finally, 72 minus 62. That also has a difference of 10. So then B asks, is this an arithmetic sequence? And yes, this is an arithmetic sequence because we have a constant difference. We were adding 10 each time. And then that allows us to find the next term. We've noticed we're adding 10 each time. Well, 72 plus 10 would give us 82. In the first lesson this week, we actually found out how to write recursive equations. And recursive equations allow us to find the next term if we know the previous term. So in this case, our recursive equation is a sub n equals a sub n minus 1 plus d. Remember, last time we wrote this as a next and now equation. So we could write this as next equals now plus d. And again, this is helpful if we know our current value and we just want to find the next one. However, if we're looking for a term further down the line and we don't want to have to list them all out, we're going to write an explicit equation. This will let us find any term. Again, d is still going to be the common difference. A sub 1 is our first term. If we want to find a particular term of an arithmetic sequence, first thing we need to do is find the common difference. We're going to subtract. Then we're going to substitute the first term in as a sub 1 and d for the difference in this equation. A sub n equals a sub 1 plus n minus 1 times d. Now, the reason we have n minus 1 is because we're starting with term 1. It's a little bit different than when you had a linear equation, and we started often with x equals 0. Then we substitute in for the term we want to know, and we're just going to evaluate. Let's look at an example. Here I have a sequence 10, 8, 6, 4, and 2. Now you'll notice the pattern is that we're going down by 2. That means my difference is negative 2. So always make sure you pay attention to the sign. A sub 1 is the first term. In this problem, it was 10. So that means my equation, a sub n, is going to equal 10 times n minus 1 times negative 2. And we're going to leave our equation like that until we're ready to find a term. This problem asks us to find the 10th term. That means we're solving when n equals 10. To find the 10th term, or a sub 10, we're going to say a sub 10 equals 10 plus n minus 1. Well, n is 10, so 10 minus 1 times negative 2. Okay, simplify that down. So it's going to be 10 plus 10 minus 1 was 9 times negative 2 10 plus negative 18. Therefore, my 10th term will equal negative 8. Check out this pattern. 6, 8.5, 11, 13.5, and 16. You might need to use your calculator to find the difference. 8.5 minus 6 is 2.5. You want to go ahead and check for each pair. Make sure it is an arithmetic sequence. Our first term is 6. So my equation then, a sub n is going to equal 6 plus n minus 1 times 2.5. To find the 15th term, we're going to substitute that n equals 15. So 6 plus 15 minus 1 times 2.5. 6 plus 14 times 2.5 means our 15th term will be equal to 41. If we have a limited number of terms, it might be harder to find the difference. The key thing here is that an arithmetic sequence has a constant rate of change. It's like a linear pattern, so think about slope. In order to find this, we're going to subtract the last term minus the first term. We're going to put that on top of our fraction. And then on the bottom, we're going to put the difference of the n's. For example, a sub 5 was our 5th term, and n would equal to 5. Then we're going to divide, and that will give us our slope. Then we can stick that in to the rest of the equation. So let's look at this pattern. 0, blank, 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 50. Again, it's a little bit harder because we're missing some things in between there. So let's look at what we do have. So we have our first term. A sub 1 is going to equal 0. And then we have the first missing the second, third, fourth. Then I have the 5th term. So a sub 5 equals 50. That's going to allow us to now find d. So to find d, we subtract our values on the top of our fraction. So we're going to take 50 minus 0 over, looking at what terms we had. Well, we had the 5th term and the first term, so we're going to subtract that. So over 50 minus 1, or 5 minus 1. So 50 over 4 is going to be our difference. Divide that out to get that d is 12.5. Then we can use that to finish off our pattern and find those missing numbers. So we should be able to add 12.5 each time and end up with the correct pattern. So we started at, whoops, that was supposed to be a 0. So we started at 0. Then our next term would be 12.5. Add 12.5 again. Add 12.5 again. Add 12.5 again. And yes, we ended up at 50. Those were our missing terms. Okay, now let's look at what we have here. We have 84 is going to be a sub 1. And then we have 48. We have to count to figure out what value that was. So 84 would be my first, second, third, fourth, fifth, sixth term is 48. Now we can think slope. So we will take 48 minus 84 on top. And on the bottom, we're going to take 6 minus 1. Figure out how many spots we counted up. So 6 minus 1 on the bottom. We have negative 36 divided by on the bottom. 6 minus 1 is 5. And our difference is negative 7.2. So subtracting 7.2, our pattern is 84, 76.8. Subtract again, gets us 69.6, 62.4, 55.2, and finally 48. Let's try a similar one, look, written in a slightly different format. Here, we want to find the 10th term of an arithmetic sequence where a sub 4 equals 20 and a sub 6 equals 32. Again, we're going to start by finding the difference. So we'll take 32 minus 20 divided by, I had the 6th term and the 4th term, so I would take 6 minus 4. So my top, 32 minus 20, is 12 over 2. So my difference must be 6. Now we need to find a sub 1 in this formula. In order to do this, we're going to fill in those other things that we know. And we do this using just one of our values. Let's look at a sub 6. So I'm going to put that in for my a sub n. So I have 32 equals a sub 1 is what I don't know, plus n minus 1. Well, I had a sub 6, so n was 6. 6 minus 1 times d, and d was 6. So let's simplify this down. 32 plus a sub 1 plus 6 minus 1 is 5 times 5 times 6. So continue to simplify this down. 32 equals a sub 1 plus 5 times 6 is 30. Subtract 30 from both sides. So a sub 1, our first value, must be 2. I'm running low on room, so I'm going to delete this. Now I want to write an equation that I can use to find any term. So I'm going to leave a sub n as my variable. So a sub n will equal, so I'm following what I had up here in B. A sub n equals a sub 1. That's what we found as 2, plus n minus 1 times d. We found d was 6. This is our explicit equation. A sub n equals 2 plus n minus 1 times 6. Now that will let us find any term. In D, it wants us to find where n equals 10. So a sub 10 would equal 2 plus 10 minus 1 times 6. So 2 plus 9 times 6, or 2 plus 54. So a sub 10, or the 10th term, is going to equal 56. Let's find the 15th term of an arithmetic sequence where a sub 3 is 100 and a sub 9 is 22. Let's start by finding d. So remember, I want to subtract the later term, 22, minus 100, because you'll see my pattern is decreasing, divided by, that was the 9th term, minus the 3rd term. So negative 78 divided by 6. Our difference is negative 13. Now we don't know what our initial first term was. So we're going to go back into the formula. And in order to find a sub 1, we need another value in there. So I'm going to work with this a sub 3 equals 100. So that's what we're going to put in for a sub n. So 100 will equal a sub 1 plus n. Well, that was our third term. So 3 minus 1 times d was negative 13. So 100 equals a sub 1 plus 3 minus 1 is 2 times negative 13. Well, that would give us negative 26. To get a sub 1 by itself, we're going to add 26 to each side. So 126 is going to equal a sub 1. Let's use that to put it back in our equation. So we're writing a general equation. We're going to leave that in form a sub n equals a sub 1, our first term, 126 plus n minus 1 times our difference, which was negative 13. Then we can use that in step D to find our 15th term. So a sub 15, we're going to have 126 plus 15 minus 1 times negative 13. So 126 plus negative 182 tells us our 15th term would be negative 56. Have a great day and reach out with questions as you're working on your assignments.